Thank you. Hello, everyone. So let's talk about SwiftUI. So how many of you have already tried SwiftUI? Can you raise your hands? Awesome. Cool. I tried it as well. I wrote several apps in that, also a game. And what I like the most about SwiftUI is actually its animation capabilities. So in this talk, I would love to speak a bit about that, and I will try to compile as much useful info about SwiftUI animation as possible, that it's possible to actually get into these 18 minutes. But let's start, for the rest of you who didn't already seen it, let's start from the basics. So let's suppose that we have this completely random view, and this is its code. We have two text views, we have some yellow background, and we would love to animate it in some way. You can see that there are several constants set as the parameters in the view modifiers. It's important to realize that almost any such parameter is animatable in the SwiftUI. So if we introduce variables instead of constants, and if we change these variables within the animation block, something like this, the view is suddenly alive, and we are able to animate it and change it. So this is really crucial part. Everything depends on your state, and if you are altering the state, you are actually able to animate these changes. Great thing is that these changes are interruptible, so you can't end up with the state where your model doesn't correspond to your view. But let me now talk about art for a while. Have you ever wondered what distinguishes good art from the mediocre one? What are the factors that actually affect how we perceive the art? I'm myself an enthusiast to digital art. I follow lots of artists and discussions, and I like these questions quite often in different artist interviews. What makes good art? And I particularly like this theory called four zones of awesomeness. It's been created by Shady Safari from One Pixel Brush. And it's about how we divide the artist's skill set and the art itself into these zones, and how these things put things together to actually let us create something awesome. And why do I like this theory is that I like to find parallels between the art and applications. Going through this chart is probably beyond the scope of this talk, but let me at least zoom on this part, the sexiness. This is about how well do you work with shapes, colors, details, and how it builds up and serves the story of the composition. And what I specifically like is this term juice. Actually, it should be pronounced juice. And it's the result of taking the reality, simplify it, and that add something more, something unspecifiable that make it to stand out. So it's like in the painting. You can have a large area of low contrast, and if you feature there a stripe of high saturation of some vivid color, your eye is immediately being drawn towards it. So for the context of this talk about animation, let me add one more box there, animation juice. And you already are asking, how can I make my animation more juicy? Well, as I said, in my personal opinion, it's about subtle improvement, not too violent, but here and there, and some unpredictable, so it's really pleasant to look at. Let's have some case study here. We have 3 squares, and we are animating them from position to position. This is default animation just by state change. It's okay. Probably it's okay for your client or your boss, but is it really okay for your users? Let's try to improve it. So first, let's add there some animation curve. It's slightly better, but I still don't like it. So let's change this animation curve to the spring behavior, and also I will feature there a slight rotation during the movement. It's already starting to look better, but I'm still not very happy about it. So I featured 2 more things. One is a custom modifier that adjusts the scale of the squares during the movement, and the other is a slight delay parameter that is set for each square. This makes it, even though you are not directly seeing it, your brain perceives it as it's more lively, as it's more organic and not so robotic. So if we compare it side by side, it's still not perfect, but I hope you get the idea how to make the animation slightly juicier and better for your audience. In the rest of my talk, I will try to describe you 3 main pillars of the SwiftUI animations that are useful, especially when you are creating juicy animations. But first, you need to understand what does it take to animate something in SwiftUI. So here we have the circle, and we want to animate it in some target area. SwiftUI simply computes the difference and then animates it along some timing curve. But what if you need something different? What if you want to animate this circle to target position, but during this movement, what if you want the circle to be scaled? You need to implement it via so-called geometry effect. Geometry effect is a custom view modifier that actually lets you interfere the interpolation and lets you interfere with the projection transformation of your view. So during the animation, you are able to alter rotations, translations, and also the position of your view. So let's have a look at it. The geometry effect has the value. This is the value that will be interpolating during the animation. And it has the main function called effect value. Here, you will be altering the projection transform, and you will be altering the appearance of your view. So let's try to build this scaling mechanism as we've seen on those squares. I feature here a new function that actually creates this curve, and we will try to fit this curve on the scale during the animation. So in our main function, we are actually building new FN transformation based on these parameters. And as expected, it works. So whenever you change and animate your view, it scales during the movement. It's simple as that. So what is it good for? As we have just seen, it's good for retransformation during the animation and for animation that starts and ends in the same state, like appearance state. It's also great for featuring some custom animation curves or animating shapes along some curve, for example, if you want them to follow some path. And it's also great for keyframe animations. So you are able to feature animation that, for example, in the first half, change the scale of your view, and in the second half, it changed the rotation of your view. Let's see some examples. There is this menu, and the movement of the green dot is being altered by the view modifier, geometry effect. In this example, this is actually a combination of 2 geometry effects. One animates the red dot along the path, and the other one makes the keyframe animations that moves and switches and rotates the texts. Geometry effect is also very useful when you are creating particle effects. So every particle, the movement of every particle is being controlled by the simple geometry effect. It is great that it is view modifier, so you are able to take this modifier and apply it on any view you want. So you can create animation, this particle effect also from your toggles or other views that you have in your scene or app. If this is not enough for you, there is animatable modifier for your hand. This is something similar, but allows you to do more drastic changes in your view, and it's also useful for animation of the things that do not normally are able to be animated, like some colors, gradients, or texts. Let's have a look at the example. We have here this score label that counts up and down according to our value. As you can see, the skeleton of our code is pretty similar to the geometry effect. We have there the value, that is the count that we want to animate. And then we have the main body. But this body is slightly different. It actually produces a new view. So for animatable modifier, during the animation, for every frame or every step of the animation, you are actually creating a new view. So how do we apply it on a view? Again, it's a custom view modifier so it can be applied pretty easily, but it won't work as easily. You need to overlay it on clear color. Why? That is probably a bug in SwiftUI, and thanks for Javier from the SwiftUI lab blog to really finding out to make it work. You may have seen that there has been two mysterious attributes, so-called animatable data. We have seen both on geometry effect and both on animatable modifier. What is it and why do we need it? Anything animatable actually depends on this protocol that features the animatable data. The animatable data are the essence here and allows SwiftUI to actually do the interpolation, to compute all the steps between when you are transitioning from state to state. So when you are animating along single values, you can use some basic scalars like CG float or double, or for pairs or multiple values, you can use animatable pairs. If you are asking, okay, but what if I need to animate along more values? What if I do have them more? You can do that also. You can either cascade animatable pairs within each other, which works. Apple uses it, for example, for edge insets. But you may guess this is not very scalable. So it's much better practice to actually implement some custom class or struct that will conform to vector arithmetics, and then you can implement your vector arithmetics by your own. So in this example, I'm building a Euclidean vector. So we have the values, and these values can be as much as we want. And we only need to implement methods from vector arithmetics and additive arithmetics like that. Why do we need just these methods? Well, let me try to explain. Let's assume we have the vector v0, and we want to animate it into new position, v1. So what does SwiftUI do? It actually first computes the difference vector v1 minus v0, and then during the interpolation, for every vector va, it's actually computed as the sum of the starting vector and the scaled vector of the difference. The scale factor is here being set by the animation curve, usually from 0 to 1. It's high school math, but it's really important to understand what's going beneath the bonnet. What is it good for? Especially for animating all types of various charts, pie charts, line charts, bar charts, whatever. The vector here, each point on this chart is actually one part of the vector. And as I'm changing them, SwiftUI already knows how to animate them because we have implemented the custom animatable data. Or you can use it for morphing the shapes. So if you divide the shapes into several control points, then you can morph it like this. Again, just by implementing custom animatable data, fill them with the control points, and that's it. I usually get the question how it is with animation performance in SwiftUI. Is it worth it? I've done several experiments, and again, there could be a single talk about it. But there are three main key takeaways that I would like you to take today. First, it's all about the number of views. The more views you have, the bigger is the chance that you will lose the 60 FPS. In my experiments, usually about 2,000 or 3,000 of views in single scene makes it already that SwiftUI starts to lose the fluency. And it's not just that all these views are moving. It may be only one view moving, but all these views actually make it buggy. In my experiments also showed that it's almost unmeasurable difference between standard view modifiers and your custom one, for example, geometry effects. So if you don't mess up really badly, you don't need to actually take care about that. And the drawing group that makes SwiftUI to actually render off-screen and utilize metal rendering is especially effective when you are doing some sort of color blending or such things, but doesn't help in the animation, for example, of movement. The interpolation is still being done on CPU. And with what I've been said now, I'm pretty sure that with these things, you are able to animate anything, create any transition in your app, and make your animation really juicy. Oh, sorry, juicy! So as a proof, I present you probably the first music video of SwiftUI, written in SwiftUI, lyrics by Google Translator. And it's really short, so we don't have music. So.
This is SwiftUI. You can animate like crazy, all the crazy stuff for your lovely lady.
Thank you. I hope I did slightly motivate you to try to play more with SwiftUI, animate like crazy. Thank you.